A narrow strip of land, barely 50 miles wide, held the power to reshape the entire globe. For centuries, the Isthmus of Panama mocked the ambitions of empires, presenting an impenetrable fortress of dense, sweltering jungle and jagged mountains. To sever the continents of North and South America and marry the Atlantic and Pacific Oceans was an audacious dream, one that demanded an epic human struggle. It was a vision of ultimate connectivity, requiring builders to conquer a landscape that actively resisted human intrusion. The first to attempt this monumental severing were the French, riding the triumph of the Suez Canal. Yet, their grand endeavor in the late 19th century collapsed into a nightmare of mud and death. They were defeated not merely by the unyielding earth, but by an invisible, relentless enemy. Tropical diseases decimated their workforce, leaving behind rusting machinery and thousands of shallow graves. The earth remained unbroken, a grim testament to the limits of pure mechanical ambition when pitted against the raw, untamed forces of nature. When the United States acquired the canal rights, the geopolitical stakes were staggering. The intense period of 1904-1914 would define a new century of global trade and naval supremacy. But the Americans inherited the exact same nightmare that had broken the French. The terrain was incredibly unstable, the tropical heat was suffocating, and the exact same rampant diseases waited in the swamps. To succeed where others had catastrophically failed, a fundamental shift in strategy was absolutely necessary. The true gatekeepers of the isthmus were yellow fever and malaria. Before a single shovel could effectively strike the earth, the builders had to survive. The prevailing medical wisdom of the era blamed miasma, a vague concept of bad air rising from rotting jungle vegetation. But a radically different theory was quietly emerging from the scientific fringes, suggesting that the true vectors of death were not the air itself, but the millions of mosquitoes breeding in the stagnant waters of the rainforest. Enter Colonel William C. Gorgas, an army physician who had previously battled outbreaks in Havana. He arrived in Panama with a singular, controversial conviction. He believed entirely in the mosquito transmission theory and understood that to engineer a canal was impossible without first engineering a massive public health revolution. His vision was not one of moving Earth, but of systematically dismantling the biological defenses of the jungle. It was a staggering logistical challenge of a completely different nature. Gorgas implemented an unprecedented militaristic campaign of sanitation across the canal zone. His teams fanned out across the harsh landscape, draining swamps, clearing vast tracts of brush, and meticulously applying oil to every standing pool of water to suffocate mosquito larvae. They fumigated thousands of homes with sulfur and pyrethrum, systematically sealing buildings with wire mesh screens. This was not merely medical care, it was a targeted environmental war against a microscopic adversary. The results of this obsessive, sweeping campaign were nothing short of miraculous. By 1906, yellow fever was entirely eradicated from the canal zone, and malaria cases plummeted dramatically. Gorgas had essentially neutralized the deadliest weapon the jungle possessed. This incredible medical victory transformed the terrifying death trap into a functional, survivable workspace. Only with the invisible threat conquered could the monumental task of physical excavation truly begin in earnest. With the workforce secured, the sheer scale of the geological obstacle came into terrifying focus. The most formidable barrier was the Continental Divide, a spine of solid rock and volatile clay that stood directly in the canal's path. To carve a channel through this 9-mile stretch, known as the Culebra Cut, required earth-moving on a scale never before attempted in human history. The mountain had to be literally dismantled piece by piece under the punishing tropical sun. To orchestrate this titanic physical struggle, President Theodore Roosevelt appointed George Washington Goethals as the chief engineer. Goethals was a brilliant, iron-willed military engineer who brought absolute discipline to the sprawling, chaotic worksite. He viewed the excavation not just as a digging operation, but as a supremely complex problem of mass transportation. Every cubic yard of shattered rock had to be efficiently loaded, moved, and dumped far from the cut. Goethals revolutionized the logistics of the project by treating the entire canal zone as an intricate, continuously moving railway system. He deployed a massive fleet of steam shovels, behemoths of iron and steel that tore into the rock with relentless fury. The dirt trains ran on a meticulously scheduled loop, constantly shifting tracks to accommodate the deepening gorge. This dynamic, ever-evolving rail network was the true mechanical heart of the excavation, a masterpiece of industrial choreography. But the earth refused to surrender easily. As the Culebra Cut deepened, the unstable geological formations triggered catastrophic landslides. Millions of cubic yards of mud and rock would suddenly shear off the canyon walls, burying steam shovels, twisting railroad tracks into useless iron spaghetti, and erasing months of grueling progress in a matter of seconds. The mountain seemed alive, actively fighting back against the deep wound being carved into its side. The psychological toll of these relentless slides was immense, yet the response was always the same. Goethals and his army of workers simply dug the machines out, repaired the shattered tracks, and began excavating the fallen earth all over again. It became a hard, grueling war of attrition between human stubbornness and geological instability. The sheer persistence required to repeatedly clear the same ground showcased a profound, almost terrifying level of human determination. Even as the cut deepened, a fundamental design problem loomed over the entire endeavor. A sea-level canal, like the one the French had attempted, was deemed impossible due to the dramatic tidal differences between the oceans and the unmanageable flooding of the Chagres River. The elegant, audacious solution was to abandon the sea-level dream and instead lift the massive ocean-going ships up and over the continental divide. This vision required the construction of the most massive lock system ever conceived. These locks would act as colossal water elevators, raising vessels 85 feet above sea level to an artificially created inland lake, and then lowering them back down on the opposite coast. The scale of the concrete required to build these gigantic chambers was unprecedented, demanding the creation of entirely new mixing and pouring technologies right there in the jungle. To operate the massive steel gates of the lock system, the engineers turned to a relatively new and transformative power source: electricity. The canal was designed to be entirely self-sustaining, utilizing the water from the artificial Gotten Lake to generate hydroelectric power. This electricity drove the massive, intricate machinery hidden within the concrete walls, controlling the colossal valves and the 50-foot thick steel gates with absolute, silent precision. The ingenuity of the lock system lay in its elegant reliance on gravity and water. No massive pumps were needed to fill the chambers. The water simply flowed down from the artificial lake through gigantic culverts, filling the locks and lifting the heaviest dreadnoughts as if they were mere toys. It was a breathtaking synthesis of heavy industrial engineering and the harnessing of natural hydraulic forces working in perfect, silent harmony. Yet this magnificent symphony of steel, concrete, and water was composed at a staggering human cost. Tens of thousands of workers, primarily from the West Indies, provided the grueling manual labor that made the canal possible. They endured the blistering heat, the deafening roar of dynamite, and the constant lurking danger of the landslides. The epic human struggle to build the canal is inextricably bound to their sweat, their immense sacrifices, and the thousands of lives lost to accidents and disease. The magnitude of the achievement becomes clear when standing at the edge of the completed locks. To witness a massive cargo vessel, heavily laden with global goods, smoothly rise up into the jungle canopy is to see a miracle of applied physics. The sheer improbability of the scene, a steel leviathan floating over a mountain range, forces a profound reckoning with the capabilities of human ambition. It is a moment where the invisible lines of global geography are tangibly bent. In late 1913, the final barriers were blown away, and the waters of the Atlantic and Pacific finally met within the man-made channels. The monumental excavation at Culebra was finally complete, the slides conquered by sheer, relentless digging. When the canal officially opened to the world, it was not just a waterway, it was a resounding declaration of humanity's newfound power to permanently alter the face of the planet. The immediate impact was world-shattering. The perilous, months-long journey around the treacherous tip of South America was instantly rendered obsolete. Global shipping routes were radically compressed, shrinking the world and accelerating the exchange of goods, cultures, and ideas. The lock system functioned flawlessly, a testament to the exacting standards of its builders, turning an impenetrable barrier into a vital, beating artery of international commerce. The legacy of the endeavor extends far beyond the physical trench. The medical protocols established by William C. Gorgas revolutionized tropical medicine forever. His obsessive campaign proved that deadly environments could be systematically tamed through scientific rigor and environmental management. The eradication of yellow fever in the Canal Zone became a blueprint for global public health initiatives, saving countless lives in the decades that followed. Similarly, the logistical genius of George Washington Goethals set a new benchmark for massive infrastructure projects. The successful integration of railroads, steam shovels, and thousands of workers into a single, cohesive machine demonstrated the incredible potential of organized human effort. The echoes of his relentless efficiency can be seen in every mega project of the modern era, from massive dams to the sprawling networks of the interstate highway system. The Panama Canal stands as a dual monument. It is simultaneously a triumph of medical science over biology and a triumph of industrial engineering over geology. The builders did not merely adapt to the harsh environment. They fundamentally dismantled and reconstructed it to serve their unprecedented vision. They proved that with enough ingenuity, discipline, and sheer willpower, even the most formidable natural barriers could be overcome. Today, as colossal ships continue to glide silently through the deep cuts and massive locks, they trace the exact path forged by those who dared to challenge the earth. The smooth operation of the canal masks the chaotic, deadly reality of its creation. The calm waters hide the millions of tons of shattered rock, the grueling years of labor, and the brilliant minds that orchestrated the entire symphony of destruction and creation. The epic human struggle to engineer the Panama Canal remains one of the most audacious chapters in our history. It is a story of conquering the invisible and moving the immovable. It reminds us that the world we inhabit is not just a given landscape, but a canvas shaped by the relentless visionary drive of those who build, forever altering the flow of human destiny.